Hi guys, welcome back to my channel. If you made it through my last little rant, then this video is just purely going to be on question 3. So determine the energy released by the complete combustion of 15.02 grams of propanol gas, and specifically propan-1-ol, which means that the hydroxy group is located on the first carbon. So what I did, I went ahead, they've given us the mass there. I've gone ahead and very roughly calculated the number of moles using the molar mass formula. The molar mass of propanol is about 60 grams. I had about 15 grams, so therefore I've got about 0.25 moles. Now we're going to use this information or this equation that we've used previously. So the amount of energy in kilojoules per mole is the amount of kilojoules divided by the number of moles. So we have negative 2011 kilojoules. So that negative just implies that it's an exothermic reaction. So we actually don't need to include the negative. We just need to remember that it's exothermic. So that is 2011 kilojoules per mole. We also have the number of moles, which is going to be 0.25 mole. And so we're just going to substitute into the equation. So 2011 is equal to the energy divided by 0.25. So 2011 times by 0.25 will give me my amount of energy. So the amount of energy, I'm just going to pop this in my calculator, 2011 times by a quarter is going to be 502.75 kilojoules. So that's all we need to do. Easy peasy. We can quickly go through some of these other questions. So describe the difference between complete and incomplete hydrocarbon combustion. So as we mentioned in the last video, if we had a compound and it was able to fully oxidize, each of those carbons were able to fully break away from the compound to react with oxygen, that would be considered a complete burn or a clean burn because carbon dioxide gas is clear. If it doesn't have a complete burn, so it might not have enough heat to break the bonds, or it might not have enough oxygen to react with the carbons, then we get these incomplete burns. Question 2, identify 3 fuels that are used in day-to-day life. We've got propane gas, we've got methane gas, we've got propanol, we've got, there's so many I feel like we use all the time. Liquid, what's it called? The LPG gas, that's another example of a fuel that's used in everyday life. Petroleum. So there's heaps of different fuels that we use. Consider the impact of a fuel that produces excessive amounts of carbon dioxide. Well, we know the impacts of carbon dioxide on the environment. So there's already a huge amount of carbon dioxide gas. Remember, it sort of acts like a blanket, like it scatters that energy back into the atmosphere, but also it can hold on to a little bit of that heat itself as well. Same with carbon monoxide. So that's very similar, but carbon monoxide, there's less of it, but it's slightly worse to deal with. Particulate matter is particularly problematic because if you are someone who's breathing in a lot of those particulates, that's when we start to see a lot of respiratory issues. And if you've ever been overseas to areas that do have high amounts of pollution and you're someone with lung issues, you've probably really noticed the difference in your ability to breathe when you go to particular places. And lastly, investigate the historical levels of CO2 in Earth's atmosphere. Is it possible to link these levels with burning fossil fuels? There's heaps of evidence out there. I'm going to be a little controversial. I'm not going to go seek any out, but absolutely, yes, these levels are linked with burning fossil fuels, and in particular, the Industrial Revolution of the 1800s. We see a huge spike in the carbon dioxide levels around this point in time. And now we're up around, I think it's 400 parts per billion, or is it parts per million? I can't remember off the top of my head. But when I was at school, this is about 10 years ago now that I graduated, those levels were around 300. So they are still increasing. So just something I wanted to talk to you about, and this is from that PDF that I had linked in the last one. This is the rant video, so if you're done with the questions, then you can click off and you don't want to listen to this. But I really liked the conclusion that they sort of came up with here. Putting a positive spin on biomass energy. So in other words, what they're saying is, we just need to plant more trees, and the trees suck up the carbon dioxide and they produce oxygen gas. So we should just produce more trees. I mean, never mind the fact that deforestation is a huge issue and that we're losing about a football field's worth of the Amazon rainforest every day. So never mind that fact. We'll just plant more trees, and that's going to increase, you know, the amount of oxygen, and we're not going to have to worry about managing our own carbon dioxide. And I don't agree with it either. So we need to go ahead and we need to reduce our consumption, and we need to reduce the amount of waste that we are producing. It's like people who go on a diet and they add things into their diet in the hopes to lose weight. You can't add things into your diet in the hopes to lose weight. You need to remove things from your diet to lose weight, right? You can't just take a pill and that issue will solve itself. It's the same with the planet. We can't just, you know, plant a tree and hope that that's going to do the job of reducing the amount of waste that's being produced by industry. All right, guys, I'm going to leave it there, and I will see you in the next one. Have a nice day.